All right, here is a video lesson on minor losses. All right, so do you know we've been writing the modified Bernoulli's, but the HL term, right? Well, we've been looking at only major terms, which is straight pipe. But there's also bends, there's gate valves, there's elbows, there's T's, even there's entrance effects. Okay. Let me rotate that to the left. They also have like entrance and exit depending on the shape. Okay. If it's rounded or sharp, okay, you have different losses. All right. Because the fluid has got to move around that particular shape and it loses energy. Okay. So HL technically is HL major plus HL minor. And HL minor is given by KV squared over 2G, where K is your loss coefficient. And you can find that depending on, and I'll go through some examples here, okay? So pretty much what you're going to end up having is that's this. We've gone through this. So the full equation for HL now can be written as V squared over 2G parenthesis FL over DH plus the summation of K's. So basically make a table or a list of all of your minor losses in the problem and add them all up. Okay, that's your minor term. So, for example, let's go right here to these different type of valves, okay? So A here is a gate valve, B is a globe valve, C is an angle valve, D we have a swing check valve, and this is a gate that goes up and down. And depending on your fractional opening that the valve is open, so 0.5 is half, 1 is fully open, and the type of valve, you're going to get a different K value. Okay, so if we're looking at this gate valve and it's half open, the K value would be 4. So you'd write that down. Typically what you have is a valve, and then you will have, scroll down here, probably 45-degree elbows. You probably have a 90-degree elbow. You might have a long radius. Depending on if they're screwed or if they're flanged in, right? And all of that stuff, you will have different K values. Okay. 90-degree, okay. These are your nominal inches: 1/2, 1 inch, 2 inch, 4 inch. Okay. So say you have two 90-degree regular elbows that are 1/2 inch, or sorry, 1 inch. So you'd have 3 for a K value because you add them up and say you had a gate valve. So you just got to figure it out. So this table lists, and these tables are in your book. You can use these K values for those. Here is a sharp kind of bend. You have to know your epsilon over D, because these lines represent epsilon over D, and your R over D. Okay, where R is your radius of that tube and D is your diameter. Okay, so you just go up, figure out that, and then scroll over. Okay. So I go through a particular problem, which is a very good problem of a combo that goes through that has a pump and minor losses, major losses, and highly make sure you watch that to know what you're doing. Okay. So minor losses, again, are valves, elbows, T's, bends, anything, constrictions, anything that's going to cause the flow to kind of change directions, and it's going to lose energy. Okay. All right. Not a very long video, but it's a good introduction into minor losses. Please take a look at that video on the combo to get a full picture. Thanks now, and have a good day.